Assalamualaikum everyone, my name is Bety Arwa Raihana, first semester student majoring in physics education, Ahmad Dahlan University. Today I want to discuss physics about lens. First of all, I want to ask, do you know what a lens is? Have you ever used a magnifying glass, camera or microscope? If so, it means you have used lens to form image, just like water, glass, parallel, plane glasses, and optical frames. Lenses are also clear objects, so they can reflect light. So, do you know what lenses actually are? How many types are there? To answer this question, please read carefully the following explanation. Okay, there are three things we will discuss. First, what is a lens? Then, types of lenses, and important part of lens. Lenses have been known to people since ancient times. In the Middle Age, Greeks and Arabs already knew and used lenses. Currently, lenses are also widely used as the main part of tools such as cameras, binoculars, or telescope, microscopes, projectors, and glasses. All of these tools are very important and useful in life. Therefore, understanding the refractive properties of lenses is very important. A lens is a clear, translucent object consisting of two curved planes or one curved plane and one flat plane. The curved surface of the lens is part of the spherical surface. Such lenses are called spherical lenses. The surface of spherical lens can be either convex, with a concave, or a combination of concave and concave. Most lenses are made of glass or plastic. Okay, convex lens or converging lens is a lens that has the characteristic that the center is thicker than the edge. This lens college like rice. Convex lenses are also called positive lenses, or can be expressed with convex lens equals convex lens equals converging lens equals positive lens. A concave lens or diverging lens is a lens that has the characteristic that the center is thinner than the edges. This lens has the property of scattering like rice. Concave lenses are also called negative lenses, or can be expressed with concave lens equal of concave lens equal of diverging lens equal of negative lens. Then this is an example of the shape of convex lens, which is divided into three types. Biconvex lenses are lenses that are convex on both surfaces. A plane convex lens is a convex lens bounded by one plane and one convex plane. Convex concave lenses are lenses that are limited by one convex plane and one concave plane. Then this is an example of the shape of a concave lens, which is divided into three types. Biconcave lenses are concave lenses where both sides are concave. Plane concave lenses are lenses that are bound by one flat plane and one concave plane. Concave plane. Concave convex lenses are lenses that are limited by one concave plane and one convex plane. To understand the main part of a lens, both a convex lens and concave lens. Pay attention to the schematic and description as shown in the following image. M1 and M2 is center point of the curved plane of the lens. M1, M2, principal axis of the lens. R1 and R2, radius of curvature of the lens surface. O, optical center of the lens. F1 and F2, the first and second focal points of the lens. The first focal point F1 of the lens is a point on the principal axis where every ray that comes from that point or appears to go to that point after being refracted will be parallel to the principal axis. In short, the first focal point F1 of a lens is the point where the incident rays meet. The second focal point F2 of the lens is a point on the main axis where every ray that's come parallel to the main axis after being refracted will go to that point or appear to come from that point. So in simple terms, what is meant by the second focal point F2 of a lens is the point where the refracted rays meet. Then agreement on lenses. In the event of light refraction in a lens, both convex lenses and concave lenses have several rules that must be mutually agreed upon so as not to produce different perspectives. These rules include the following. Number 1. All paintings are created by bringing lights from left to right. Number 2. The object distance is positive if the object is in front of the lens and negative if the object is behind the lens. Number 3. The image distance is positive if the image is behind the lens and negative if the image is in front of the lens. And number 4. The nature of the image is real if it results from the direct intersection of reflected rays and virtual if the result from the intersection of extended reflected rays. Then, look at the following illustrative video.
Lenses that are thicker at the middle are called convex lenses. These lenses cause parallel light rays to converge to a single point, called the focal point. When light rays pass through the lens, they do not travel in straight lines, but rather bend slightly inward. This phenomenon is called refraction. When light rays pass through the lens, they refract and converge to a single point to produce an image. Because the image passes through the lens to the opposite side, it is projected upside down. This process alone, however, is not enough to produce a sharp image. This is because, strictly speaking, a spherical convex lens alone cannot cause light to converge to a single point. The focal point where light rays passing through the center of the lens converge differs slightly from the focal point where light rays passing through the edge of the lens converge. This is called spherical aberration. In addition, color fringing may occur. This is called chromatic aberration. When light passes through a convex lens, the focal point for red light, which has a long wavelength, is farther away from the lens than the focal point for blue light, which has a short wavelength. This causes colors to shift. As a result, colors appear to bleed. Making light converge neatly to a single point requires technology. Since the direction in which spherical aberration occurs in a convex lens is opposite to a concave lens, through a combination of two or more lenses, light rays can be made to converge to a single point. This is called aberration correction. Chromatic aberration can also be corrected by combining two lenses. To achieve the most beautiful images possible, actual camera lenses incorporate multiple individual lenses that correct focus and color bleeding. Lenses for single-lens reflex cameras are made up of a large number of lenses. Each lens is responsible for such roles as adjusting colors, distortion, and focus, as well as changing the focal distance. Canon takes pride in its diverse lens lineup. Each model features technology designed to capture beautiful images.
Okay, we are done discussing lens material. Thank you for watching my video. See you again. Assalamualaikum warahmatullahi wabarakatuh.